Hello friends, welcome back to my channel, Lecture 2 Units and Measurements. In this video, we're going to learn what are the SI prefixes and scalar and vector quantities in details. Friends, I have already uploaded the first video on units and measurements. If you haven't watched that video, please go and check out it. It will help you to understand today's topic more clearly. So, what are the SI prefixes? Friends, when we measure the things or when we do the calculations on scientific calculator, sometimes numbers are very big and sometimes numbers are very small. So writing so many zeros become very difficult. To solve this problem, scientists use the SI prefixes. SI prefixes are used to make the numbers more manageable. It simplifies the large or small measurements. For example, instead of writing 1000 meter, we can easily write 1 kilometer. Instead of writing 0.001 second, we write 1 millisecond. Instead of writing 0.000001 gram, we write 1 microgram simply. So, SI prefixes help us to write large or small numbers in smart ways. They save time and they avoid the mistakes. And the SI prefixes are internationally recognized. A scientist in India and one scientist in UK both understand that 1 kilometer is equal to 1000 meter. It ensures the uniform communication between the people. This table shows the standard prefixes. SI prefixes gives us information about multiple or sub-multiples of a unit by using power of 10. Now here you can observe that 1 kg is equal to 10 raised to 3 gram. 1 nanofarad, nano means 10 raised to minus 9. So 1 nanofarad is equal to 10 raised to minus 9 farad. 1 megawatt is equal to 10 raised to 6 watt. Mega means watt, 10 raised to 6. 1 millimeter is equal to 10 raised to minus 3 meter. So you can observe that the prefix is placed before a unit to indicate how many times larger or smaller that unit is compared to the base unit. In physics, when we solve the numerical, we want all the unit, it should be in same system. So these prefixes are very helpful for that. First example, convert 5 kilometer to meters. Now we know that 1 kilometer is 1000 meter. So we simply multiply 5 to the 1000. So we get 5 kilometer is equal to 5 into 1000. We get the 5000 meter. Second example, convert 0.05 meter to centimeter. Now we know that 1 meter is equal to 100 centimeter. So we multiply 0.05 by 100. We get the 5 centimeter. Now third example, convert 5 micrometer to meter. Micro means what? It's a 10 raised to minus 6. So 1 micrometer is equal to 10 raised to minus 6 meter. So we simply multiply here 10 raised to minus 6. So we easily convert from micrometer to meter. Convert 1 centimeter square to meter square. Now we know that 1 centimeter is equal to 10 raised to minus 2 meter. Centimeter is what, guys? It's a 10 raised to minus 2. So 1 centimeter is equal to 10 raised to minus 2 meter. Squaring on both sides. So we can easily say that here it's 1 centimeter square is equal to 10 raised to minus 2 raised to 2 meter square. So by using the indices rule, a raised to m raised to n is equal to a raised to m into n. So here we get 1 centimeter square is equal to 10 raised to minus 4 meter square. Take more example, 2.6 centimeter square is equal to 2.6 into 10 raised to minus 4 meter square. 1.5 centimeter square we can easily convert into by multiplying 10 raised to minus 4. So 1.5 centimeter square is equal to 1.5 into 10 raised to minus 4 meter square. Next example, convert 150 microfarad to farad. Now micro here stand for the 10 raised to minus 6. So 150 microfarad is equal to 150 into 10 raised to minus 6 farad. Next, 2 gigahertz to hertz. So what is the giga? Giga is 10 raised to 9. So 1 giga is equal to 10 raised to 9. So we can easily convert 2 gigahertz by multiplying 10 raised to 9. So 2 gigahertz is equal to 2 into 10 raised to 9 hertz. Next, convert 72 kilometer per hour into meter per second. First we convert 1 kilometer per hour into meter per second. So we know that 1 kilometer in meter 1000 meter. 1 hour means what? 60 into 60 seconds. So 1000 divided by 60 into 60 seconds, we get 10 upon 36. So 0 will get cancelled here. So we get here 10 meter upon 36. Now again simplify it. So we get the 5 upon 18 multiplying factor. So simply multiply this 72 kilometer per hour by 5 upon 18. So we can easily convert into the meter per second. So 72 kilometer per hour is equal to 72 into 5 upon 18 meter per second. 72 kilometer per hour is equal to 20 meter per second. So we can easily convert. So always keep in your mind, when we convert from kilometer per hour to meter per second, we have to multiply 5 by 18. So we can easily convert that number into the meter per second. One more last example. Convert 1 kg per meter cube into gram per centimeter cube. So guys, here we have to convert from kg per meter cube to gram per centimeter cube. Again, we do the same thing. 1 kg, we know that 10 raised to 3 gram. That means what? 1000 gram. And meter, it will be your 10 raised to 2 centimeter. That means 100. So here 10 raised to 3 gram upon 10 raised to 2 centimeter cube, we get the calculation 10 raised to 3 upon 10 raised to 2 raised to 3. That means we get 10 raised to 3 upon 10 raised to 6. So here by using the indices rule, we can easily calculate that we get here 10 raised to 3 minus 6. That means 10 raised to minus 3 gram per centimeter cube. So to convert 1 kg per meter cube, we have to multiply 10 raised to minus 3 gram per centimeter cube. Now next important point, scalar and vector physical quantities. First we'll learn what is the scalar quantity. The quantity which has only magnitude but not direction, that quantity is known as the scalar quantities. For example, 5 kg, mass is 5 kg. Only magnitude matter here, no direction. So mass, it's a scalar quantity. Temperature is 30 degrees Celsius. No direction involved. That is, it's a scalar quantity. Time is 60 seconds. So it's just measure a duration. Distance, it's 10 kilometer. Here the total length is given but not given the direction. So distance, it's scalar quantity. If they mention direction, so we can call it a displacement, not distance. So here only distance, it's a scalar quantity. Speed 40 km per hour. Actually they have again not mentioned the direction. So speed, it's scalar quantity. If they mention the direction, so we use here velocity instead of speed. So mass, temperature, time, distance, speed, energy, work and power, these are all the scalar quantities. Scalars are represented by a number and unit only. For example, mass is 2 kg. Number and unit. Time 5 seconds. No arrow or direction is needed. So what are the main characteristics of scalar quantities? It requires only magnitude, not direction, and they can be added or subtracted using simple arithmetic operations. So this is about the scalar quantity. Now what is the vector quantity? Quantity which has magnitude as well as direction, that quantity is known as the vector quantity. For example, displacement 10 km towards north. Here they have mentioned the distance along with the direction. So displacement, it's a vector quantity. Velocity 40 km per hour to the east. Actually here again they have mentioned the direction along with the magnitude. So velocity, it's a vector quantity. Acceleration 9.8 meter per second square downward direction. So what is the acceleration? It's the rate of change of velocity. They have mentioned here downward direction. So acceleration is a vector quantity. Same force 50 Newton upward. So here also they have mentioned the magnitude as well as direction. So what is the vector quantities? Quantity which has direction as well as magnitude, that quantity is known as the vector quantity. Vectors are denoted by an arrow symbol above the quantity. Here F vector. So friends, what are the characteristics of vector quantities? Both magnitude and direction required. Second, they are oftenly represented graphically by arrows. And third important, vector quantities are added using vector addition rules, not a normal simple arithmetic operation. So this is about the vector quantity. Hope so you understood this lecture. So friends, if you found this video helpful, don't forget to like and share with your friends so more students can benefit it. Thank you so much for your support.